Today we are going to discuss example number 4. Find a quadratic polynomial, the sum and product of whose zeros are -3 and 2 respectively. So today you do not have to find the zero of a polynomial, but you have to find the polynomial instead. And you have been given that the sum of zeros is -3 and product is 2. So let's begin. To find the quadratic polynomial, we are going to assume it as ax square plus bx plus c and let its zeros be alpha and beta. So today what we are going to do is we are going to assume that we have any polynomial because we do not know what exactly our polynomial is, and we are going to assume it as ax square plus bx plus c. You can assume it as anything, but remember that it should have a power x square and it should have x and a constant term. Also, we are assuming the zeros to be alpha and beta. You can assume any variables. There is no need to assume them as alpha or beta. You can assume x, y or anything, but it's the least confusing when you assume them as alpha and beta. So now we have alpha plus beta is equal to -3, which is equal to minus b by a. So we are aware of this equation that the sum of the zeros of a quadratic polynomial is minus b by a, and we are going to use this. And we also know that alpha beta is equal to 2, which is equal to c by a. So we know that the product of zeros is c by a. So these two are very important relationships that we are going to use here. So let's see how we are going to use them. If alpha and beta are zeros of any quadratic polynomial, then quadratic polynomial equation can be written as, so basically here we have our quadratic polynomial, and what we have done is that we have taken a common from ax square plus bx plus c. Now why we have done this, let me show you the next step. So now you can see in this step that we have got this particular equation. Now how did we get this? So right here you can see that here we have got a b by a term, and what we are going to do is that we are going to replace this b by a by minus of alpha plus beta, as you can see from this equation, and we are going to replace this c by a as alpha beta. So when you do all this, you get this as the final equation, wherein x square minus alpha plus beta into x plus alpha beta equal to 0 becomes the equation of the quadratic polynomial. So now the next step which we are going to do here is that we are going to put in the value of alpha plus beta and alpha beta. So let's see what we get after putting the values. So we get x square minus of 3 into x plus 2, and the final polynomial which we get here is x square plus 3x plus 2. So one quadratic polynomial which fits the given conditions is x square plus 3x plus 2. Now what I am trying to say here is that this is not the only answer that you're going to get. This is one of the answers, because when you check that any other quadratic polynomial that fits these conditions will be of the form k into x square plus 3x plus 2, where k is real. So whenever you multiply a real number with this polynomial that we just derived, you are going to see that all these polynomials are going to satisfy the given conditions in the question. So there are going to be multiple answers, because you can replace the value of k with anything. You can put in 1, you can put in 2, 3, anything, any real number. So this is what is very important for today, and this was the example. So we have discussed how to find a polynomial using the sum of its roots and the product of roots. So I hope that I've made this question very clear for you today, and you will be able to understand and solve similar types of problems. Now what we are going to discuss is a concept extension of this relationship of coefficients and variables. So let's move on to that. Do you think A similar relation holds between the zeros of a cubic polynomial and its coefficients. So you might already be thinking about this, or now you can think about it. So have you really thought that is there any special relationship between the coefficients of a cubic polynomial and its coefficients as well? So we are going to see what all we can get today. So we are going to discuss whether we can get similar relations between coefficients of a cubic polynomial and its zeros. So we are going to see today if similar relationships exist for a cubic polynomial as well. So moving on, let us consider p of x is equal to 2x cubed minus 5x squared plus 14x plus 8. So this is the cubic polynomial that we are going to be using today to find out if the relationships that we discussed about earlier exist for this particular polynomial, and if we are able to find some relationships, in the end we are going to generalize them so that you can use those formulas to find similar things for a cubic polynomial. You can check that p of x is equal to 0 for x is equal to 4 minus 2 and half. Since p of x can have at most 3 zeros, these are the zeros of the given polynomial. So now how do we find the zeros of a cubic polynomial? So basically the best method is to try and put in values, because usually there is no direct way of factorizing a cubic polynomial. You can try putting some values, and then for example you had put in minus 2 and you got 0. So now x plus 2 is going to become a factor of the given polynomial, and then you can divide the given polynomial by x plus 2, and from there you can get the more factors. So this was a brief about how you can factorize the polynomial, but today we are actually not going to factorize it. We are just going to take a look at the zeros and the relationship that they have with the coefficients. So now we are going to verify the relationship between zeros and the coefficients of 2x cubed minus 5x squared plus 14x plus 8. So we are going to verify if there is a relationship, and we are going to check if this happens for cubic polynomials as well. So first of all, we have sum of zeros is equal to 4 plus minus 2 plus half, which is equal to 5 by 2, which can also be written as minus of minus 5 divided by 2. So if you try to take a good look at it, you can see that if you take the coefficient of x square divided by 2 and take a negative of it, you will actually get 5 by 2. So what I am saying is that here you are getting minus of coefficient of x square divided by coefficient of x cube is actually equal to the sum of zeros. So this is the first relation that we have got for a cubic polynomial. Let's see what the next relationship we have. So we have the product of zeros, which is going to be 4 into minus 2 into half, which is equal to minus 4, and which can also be written as minus 8 divided by 2. So if you see, minus 8 is actually the constant term here. So let's see what the final relation is. So the relation is going to be minus of constant term divided by the coefficient of x cube. So if you remember, for quadratic polynomials, we had coefficient of x and divided by coefficient of x square. Here we have coefficient of x square divided by coefficient of x cube. So you can see that even the product of zeros and this particular relation actually holds true for a cubic polynomial. So these are the two relationships that we had discussed earlier for quadratic polynomials, and now they hold true for a cubic polynomial as well, but there are little modifications. So let's see, and now you can understand that there are some relationships for cubic polynomials as well. However, there is one more relationship here. Consider the sum of the products of the zeros taken two at a time. We are going to have. So For a cubic polynomial, the previous two relationships are true, but there is one more relationship which is going to be, in this we are going to take the sum of the products of the zeros taken two at a time. Now what does this mean is that we have three zeros and we are going to take two zeros at once, multiply them. Then we are going to take two other zeros, multiply them. Then we are going to take two zeros, multiply them and add all these three products. So let's see what I am actually talking about. So you can see here that we are taking two zeros, which are 4 and minus 2, multiplying them, adding them with the product of these two zeros and then adding them to the product of these two zeros. So from here what we get is minus 8 minus 1 plus 2, which is equal to minus of 7, which can be written as minus 14 by 2. And when you see this, you are going to get this expression. You are going to get that this particular relation is basically this particular formula, you can say, which is minus of coefficient of x divided by coefficient of x cube. So the coefficient of x for this polynomial was 14, and when you divide it by the coefficient of x cube, which was 2, and take a negative of it, you are going to get minus 7. So this is a new relationship that we have got for a cubic polynomial. And we were able to understand this using an example. Now what we're going to do is that we're going to have a general formula for these relationships. So in general, it can be proved that if alpha, beta and gamma are the zeros of the cubic polynomial ax cubed plus bx squared plus cx plus d, then so we have a cubic polynomial which is right here. You can see ax cubed plus bx square plus cx plus d, and these three are the zeros. So now we are going to take a look at the three different relationships and we are going to give them a general form so that you can apply it to other polynomials as well. So the first relationship is alpha plus beta plus gamma is equal to minus of b by a. So b is the coefficient of x squared and a is the coefficient of x cubed. Next up we have alpha beta plus beta gamma plus gamma alpha is equal to c by a. So this is basically the new relationship that we just discovered, and here we have the coefficient of x, you can see, divided by the coefficient of x cube again, and the last equation is alpha beta gamma is equal to minus d by a. So you can see that these are the three equations and these are now generalized for all cubic polynomials. So you can use these to find cubic polynomials, you can use these to find zeros, and various types of other questions are going to be there as well. We are going to discuss different types of questions, so don't worry about it. I hope that you had fun watching this video and you were able to understand the example that we discussed in this video, along with this and a new concept that we saw wherein we were able to understand how a cubic polynomial has some different relationships, and I hope that you will be able to remember these as well. So thank you so much for watching.